Drones and electric vertical takeoff and landing, or eVTOL aircraft, aim to be common modes of transportation and delivery.
Electric vertical takeoff and landing aircraft have the potential to completely change how we live and work.
Small drones can deliver packages that can have life-changing effects, like medical supplies and medicine.
Today, we essentially have flying laptops. The possibilities of what they can do are limitless.
With drones, DroneUp has changed the way Walmart is able to deliver its packages in a fraction of the time of traditional methods.
It's access. We are going to democratize speed, and that's where drones come into play.
I'm Dawn Zoldi, a former military attorney. Even then, I knew that drones were going to change the world, and today we see this coming to fruition. It's so incredible to be a part of history in the making. It's time to go behind the wings. Think about hailing an Uber or a Lyft. Well, instead of getting into that car, you're going to hop in one of these. Instead of possibly sitting an hour in traffic, you're going to get there in 10 minutes. We're here at Archer's headquarters in Palo Alto, California for two big things today. First, the flight test of the Maker. In fact, it's the first transitional flight we're going to see. We're also going to get a sneak peek at Archer's Midnight aircraft. That's their commercial model. And the vision here is for it to be a ride share. It's going to change the face of transportation. We're here inside the lab, and behind me is the Maker. We're going to see this aircraft fly later today. It's a demonstrator, and they're doing flight testing. So what they're going to show today for the first time is transitional flight. That means taking off vertically in a hover to forward flight, where the wings are providing most of the lift. So to understand better how this thing flies, we're going to hear from the Chief Operations Officer here at Archer, Tom Muniz.
So I was a young engineer doing airplane design work and had the opportunity to start working on new, exciting electric airplanes. And back 10, 12 years ago, that was like a crazy idea. Electric airplanes, like what does that even mean, right? But batteries are continuing to get better, motors are continuing to get more lightweight, and so actually you could make a new type of airplane to do some really cool stuff, putting all the technology together. So that's kind of what you see behind us here today.
What's different about it than designing just a conventional aircraft?
One of the unique things about the aircraft that we're developing here at Archer is that it's not just electric, but it also takes off and lands vertically. So it doesn't need a runway, it takes off like a helicopter. But unlike a helicopter, it doesn't have one big rotor system. It actually has many small propellers all around the aircraft. And the way you can do that is by having electric motors, which you can scale down, and then you have this inherent redundancy in the system, meaning any of the motors can fail and the aircraft still flies safely. That's only enabled by electrification. Super cool.
I imagine the lower cost for things like maintenance could also translate into savings for consumers. Like if someone wants to fly on this aircraft, like how does that translate?
We envision these airplanes flying in networks where they're kind of hopping one flight to the next, doing lots of trips per day. And what that translates into is really low operating costs, and that translates into low ticket prices. In the future, you'll be able to get out the Archer app, and you'll be able to say, hey, I'd like to go to this destination, and then that'll reserve a seat on a flight like this. Then you'll be able to go to the vertiport, and then you'll take your Archer to wherever you want to go.
So think about hopping on a plane virtually from anywhere, whether it's from a dock, a rooftop, or a parking lot. And once you start cruising, they rotate down and fly like propellers on an airplane. Here we are at the tail of the aircraft. Now, on a normal airplane, this is where the exhaust would normally come out. Noticed? There is none. So what's so special about electric? A couple of things. Quieter, safer, more sustainable and accessible. Those are all bonuses. On the downside, batteries can have limited lifespans and can be heavy. We are at the airport right now and we're getting ready for the flight test demo. It's gonna be awesome. So we made it to the Salinas airport. This is an active airfield and we're getting ready for the flight test of the Maker. It is an uncrewed aircraft that's about 80% of the production model that Archer is putting out for urban air mobility. They've gone through a small drone demonstrator to the larger Maker 80% demonstrator to what we're going to see later, their big production model for urban air mobility. So the future is here.
November Oscar Bravo Whiskey.
We've been cleared for takeoff, and what we're seeing now is the plane is lifting vertically. It's going to hover. Pretty cool. As it starts, the rotors are facing down, right? And so when it gets up there in that hover, they start tilting forward, and that's where you see the transition to forward movement. This vehicle is uncrewed, right? So there's nobody on board, there's no pilot up there, but you've got about 6 folks in a trailer making sure that everything's on track. This is a real live flight test. So they're proving their concept here, and they're well on the road to FAA certification. Really exciting times to see this in action here with the Maker. We've seen the demonstration model called Maker. In fact, we've seen it fly. And now this is the production model called Midnight. This is the one that's going to fly you around New York City. There are some similarities to the demonstration aircraft. Just like the Maker, this also has 6 rotors that tilt. So that's what's going to create the vertical lift. And this one's bigger. The Maker is a literally 80% solution. This is the full scale model that can fit 4 passengers and a pilot. The vision is urban air mobility, or UAM. And this is flying people around cities, short distances.
So nice to meet you.
You're well on the path to certification with the FAA. In fact, today's flight demonstration with the Maker, can you explain the significance of that?
The industry has largely been focused on research and development. While the technology is really cool and we can build really fast, high-flying planes, we want people to be able to use them and use them on an everyday basis. We recently showed a flight test of our demonstrator aircraft Maker, and that showed the capabilities of what these vehicles can do. It shows you how fast they can fly, but importantly, it shows you how quiet they really are. That was a big step in helping the public see that these vehicles are coming to market really soon. We've recently partnered with United Airlines. They've been a great partner to Archer, where they're buying aircraft from us and helping us stand up this entire industry. Electric vertical takeoff and landing aircraft have the potential to completely change how we live and work. So if you can imagine, not just driving to work every day, but potentially flying to work every day. Not just going long distances to take vacations, but flying somewhere locally and doing it on a more regular basis. That's the world that I want to live in.
That's the world I want to live in too, and thank you so much for helping create it. As one example of many that we're seeing now, that was so amazing learning about these aircraft and also getting to see one fly. You know, the FAA always talks about a crawl, walk, run approach. Well, guess what, everybody? We're flying. Small drones can have big impacts. While electric vertical takeoff and landing aircraft can carry people, small drones can carry packages that can be life-changing, like medicines and medical supplies. About 60 million Americans, or 1 in 5, live in rural areas, and drones can be the difference between hours to minutes to get those folks the urgent medical equipment that they need. The Choctaw Nation's reservation in Oklahoma occupies about 11,000 square miles. They are doing medical deliveries that are going to change the world. So James, what's at stake in terms of medical drone deliveries?
Well, in terms of medical drone delivery, we're looking at solving that disparity that we have between urban and rural communities. There's a lot of things that have happened with technology that have equalized the quality of life and quality of health between urban and rural areas. But transportation is the last part. And that transportation challenge, being a long way from medical clinics, medical services, being a long way away from emergency response personnel, those things impact health outcome. Unfortunately, in the 21st century in the United States of America, we still have health outcomes that are determined a lot by your zip code. Drones, we believe, are going to help equalize that. We represent what most rural communities look like. Our reservation looks like other Native American reservations. We look like other rural communities.
Tell us a little bit about the medicines or the equipment that drones can bring to people in a quicker manner that can save lives.
We looked at a simple case of access to EpiPens and potential for saving lives. There are dozens and dozens of people every year that die because they don't have access. Well, that's a very small, simple item, but getting it to somewhere quickly is the challenge in rural areas. A lot of things that in the right situation you need immediately. You can't wait 45 minutes or an hour. Drones are perfect for that.
So James, we're going to see a demo of a medical drone delivery, but this package you're holding is something that could be used in a real world scenario. So tell us a little bit about this.
Yeah, it's surprising, in emergency situations, a lot of times it doesn't have to be very big packages or very much equipment. And it's amazing what we can pack into these small packages like this. So
let's see what we got here.
We've got quite a bit. There's multiple situations that we can deal with this type of a kit. But you could imagine something like this could also be packed with insulin, we could have it packed with EpiPens, we could have it anti-venom, all sorts of things to face situations that we might see in a rural area like this.
So what you're going to see is this drone that's going to have a 5-pound package loaded on it. It's going to have bottles in there that are filled with liquid, which basically simulate either medicines or critical medical samples that need to get from one location to another. We're going to see it take off, and then we're also going to see it land. This test flight illustrates one of the hardest use cases where there are liquids on board, about 5 pounds. The conditions are windy. So the key here is to show the stability and reliability of the drone so it can fly and get these medicines to where they need to go safely. This is one of those examples where you're basically going to simulate the hardest use case.
We're going to try to do the worst case scenario. And that's what the FAA likes to see as well, because whenever they're testing, they say, okay, what's the worst case of this situation, and how are you going to demonstrate you can do that safely?
Well, you did some of these flights, so could you give us a real-world kind of example of if this was driven by car, how long this would have taken versus how long it actually took you to do the same delivery with a drone?
Even if you're only flying at 30, 35 miles an hour, if you look at putting a car on the ground from the initial point to the destination, and then compared that with the drone flight, and we cut the time almost in half.
That's significant, especially if we're talking about life and death situations. As part of the Federal Aviation Administration, or FAA's Beyond program, companies can come to the Choctaw Ranch and safely test out the most difficult use cases, whether drone delivery, beyond visual line of sight flight, to make sure that they're doing this in a place where the air and ground risk is minimal and to inform decision making. While the testing and experiments occurring here in the Choctaw Nation for drones and medical delivery are unique, the impacts they're going to have will be universal. In Baltimore, Maryland, Mission Go is pushing the envelope even further for medical drone deliveries. In 2019, they delivered the first organ by drone successfully to a transplant recipient.
We see drones as a tool of the future. Medical transport is critical. Time is always of the essence. Nobody wants to be waiting around for blood. Nobody wants to be waiting around for the organ that they need. Now, I'm not a doctor, I'm a pilot, but what our doctors do tell us is that for every minute an organ is outside of the body, it's degrading, it's dying. The organs don't want to be outside of the body, they want to be inside of the body. Our organ transport and procurement, transportation across the country, they do a really good job, but that's not to say that it can't be better. Uncrewed aircraft have a really unique role in making that whole process better and making the recipients on the other side, their quality of life better. In 2019, Dr. Joe Scalia with the University of Maryland Medical Center came to us with an absolutely wild idea of transporting a human organ on board an unmanned aircraft. What is the art of possible, but we were up for the task and the challenge, and we did just that.
The long game with these technologies is that we'll be able to limit the amount of time that expires between explant and implant. We'll also be able to reduce the cost of the shipment of organs. We'll have access to immediate transportation, certainly be more efficient, and I think there are a lot of upsides. In this initial series, just trying to organize the logistics, I think, is really critical to moving forward. So this is really about getting it right, working as a team, you know, a group of surgeons, engineers, drone folks. Yeah, it's a big group of people to bring together, but we've been able to do it, at least here today, so that's exciting.
It's cleared for launch. Let's make some history.
Launch. The night came of April 2019 where we flew the first human kidney for transplant over the city of Baltimore. Now, mind you, the task of doing that was monumental. It was not as easy as just somebody showed up with a kidney, we put it on the aircraft and pushed a button. There was more than 400 people involved to make that happen. It was a literal village to make this a success. And in the end, while it was a short flight, it was around 3 miles in length, the fact is that we did it, and it was successful.
Confirming Helmel's active, temperature's appropriate, organ doesn't appear to be injured at all. Looks like a perfectly transplantable organ.
And it proved that uncrewed aircraft could be used for more than just taking pictures or flying around for fun, but it could literally be used to save lives and transport a human organ in a safe manner to somebody who needs it, and they need it right now. It's an excellent tool that we can have in the box to supplement a huge endeavor that we're trying to create better quality of life for patients in the end.
With medical delivery by drone, small packages can have a massive impact. Since the COVID-19 pandemic, drone delivery has really taken off. Why? Because they're the ultimate social distancers. In a small town in Arkansas, a revolution is taking place in the world of last mile delivery. We all know the traditional way of shopping. You have to get in your car, drive to the store, pick up whatever it is you're looking to buy, and then head on home. But with drones, I can get any of this delivered right to my backyard, even a rotisserie chicken. As one example of many that we're seeing now across the country, Walmart has teamed up with DroneUp to bring a number of their products from the store to your door by drone, more conveniently and quickly.
Each one of these Walmarts becomes distribution centers with products that are custom fitted for the audience around them. Being able to deliver from the Walmarts to those residences within that range allows us to serve millions of customers every day.
Tom, how would you describe this moment in time in terms of the drone industry?
If you think about where we are in the evolution of the drone industry, specifically related to drone delivery, prior to the pandemic, there were no drone delivery operations going on in the United States. Today, in addition to what others in the industry are doing, we have 34 locations delivering to 4 million customers. That's happened in just a few years. And now with the FAA regulations evolving and the technology evolving and the communities realizing this is really happening, we had mayors of cities all over the country asking if we would come into their cities and do the very same thing. You're seeing partnerships like the one we have with Walmart. I can't even imagine what you're going to see over the next 2 to 3 years.
From those initial days when you were doing these tests with Walmart for COVID-19 test deliveries to today, your operation has evolved so much. How has it evolved?
It's evolved a lot. In those early days, there were no off-the-shelf drones designed for delivery. Today, we've got drones that are custom built and designed with all kinds of safety protocol, autonomous software, integrated with airspace management so that we can deconflict and maintain safe airspace. Today looks nothing like it looked even 2 years ago.
What is your vision of the future for drones?
My vision of the future is that we're going to be, within 10 years, we're going to be delivering about 5 billion packages a year. If you think about that, that's probably 25% of the total delivery market. And that's from a technology that was not even being used just a few years ago. When we talk about the last mile, we recognize drones aren't the final solution to the last mile. Over the next 10 years, you're going to see the last mile revolutionized. And we believe that it's going to be autonomous aerial, autonomous ground, and electric vehicles. We know the part that we play in it, and we know that we're going to change the last mile over the next 10 years.
DroneUp continues pushing the boundaries of drone delivery. Its partnership with Walmart is going to change the way we all receive packages. It was so great to meet you. Pratibha, what kind of impact do you think drone delivery can have on everyday people?
Our customers have told us that Convenience and saving money is really important to them. They want to have express delivery for things that they need in a pinch, and that's where drones come into play. It's access. We are going to democratize speed. If somebody lives in rural America and wants access to prescription drugs and regulations allow us to deliver prescription drugs, we are able to do that. And the third one is sustainability. So drones mainly operate through electricity, and it prioritizes planet and making sure we are being sustainable in how we use our resources.
How do drones fit into your last mile delivery strategy?
We've talked about Walmart's footprint, 4,700 stores within 10 miles of 90% of the US population. So 120,000 SKUs or items are available for express delivery for our customers. The maximum weight that we can deliver right now is 10 pounds, but we're working with FAA, local state regulators, to expand that. It's not about the technology itself, but what problems the technology is going to solve.
So in your experience, what are the top items that people are ordering for drone delivery right now?
The top items are cookies and cream ice cream, paper towel, lemons, and then rotisserie chicken. Isn't it fun that we are delivering rotisserie chicken to people's backyard?
I personally can't wait to get my rotisserie chicken delivered to my backyard. I mean, think about it. With drone delivery, chickens really can fly. This sounds like it's going to be in the future, but it's happening now in Bentonville and coming to a town near you. Now that you both have explained how Walmart drone delivery works, I'm so excited to experience it for myself. I'm getting s'mores drone style. I'm here with Ken. He is the hub manager here at Bentonville, Arkansas, Store 100 for Walmart. And you're going to show me how to place a delivery.
Absolutely. It's easy as any web order you've ever made.
All right, let's do it.
All right. All you got to do is click in your address.
All right, here we go. Okay, super easy. I put in my address, and now here's all the different things that I could order, but I want to order stuff to make s'mores. So what do I do?
You just scroll to the items you want. So in this case, you want s'mores, so you just click on the item to add to your cart.
And it looks like we're good to go. So then I go to my little cart.
Yeah. And then once you hit submit, the order process begins.
Ken, that was so easy. That took me less than 2 minutes.
Yeah, nothing's different than any other order, except how it gets to you.
So I placed the order, Walmart got the goods, and now what happens next?
Now we just load it up in the box and get it ready.
Okay, very good.
You want to load it?
Sure. All right, in go the grams, in go the chocolates, and the mallows.
All right, all that nice and center in our box, and close it up. And that's it. Let's get it flying.
Package is loaded. What's next?
Ready for takeoff.
So Ken, we're up on the roof here of the hub, but what is this behind us?
That's our remote pilot and command. He's the one that manages the flight. The aircraft is completely automated, but he still supervises all operations.
Safety is job number one.
Of course.
Good, because I sure hope that my s'mores arrive safely. There go my s'mores. In the air, we see the drone flying with precision and reliability to its ultimate destination. On the ground, we got to witness firsthand the delivery by drone of goods right to the customer's doorstep. So here we are at the landing site, so tell us what we're going to see.
It's going to travel for us here at this hub. We fly at 115 feet. It'll fly in and it'll descend down to 80 feet, which is our safe delivery altitude, and then it will rappel down on a line your box.
I think I see it coming right now.
Yep, there it is. It is, because there it is.
And the package is descending. Wow, that comes down pretty fast.
Puck captured.
All right, here it is, the big reveal. And there they are, fully intact. So when you're at home and you don't want to go out, but you have a hankering for a s'more, drones, we're going to make that happen for you. So I got to experience this myself today. Absolutely unbelievable. From order to delivery, less than 30 minutes. I can't wait
until this comes to Colorado Springs.
We look forward to visiting.
From flying taxis to drone deliveries of groceries and even human organs, we've seen how drones and eVTOLs are transforming everyday life.
There's a real opportunity here to be able to move a lot of people into the air and allow them to not only just save time, but actually figure out what they want to do with that time.
Today, people are using drone delivery as a convenience. In the future, it will become something that people simply can't live without.
Not only will we see our health benefit from it, but we'll see this convenience that will make our lives much more enjoyable.
Flying is really not new. We've been doing it for a long time now. Artificial intelligence, sensors are all getting integrated today to make these flying laptops even smarter and more efficient than they ever have been.
These technologies increase access, increase speed and efficiency in ways we've never seen before. They're on the way to becoming a huge part of our daily lives. As this technology continues to mature, keep an eye in the sky for a drone near you.
The James Webb Space Telescope is the largest and most powerful telescope in space, uncovering secrets of how galaxies were formed and how the universe was created.
The James Webb Space Telescope is unraveling the mysteries of the universe.
We'll meet the scientists, engineers, and visionaries who brought this telescope to life.
The early days, just a few people, whiteboard, how do we build something that could actually work?
We're on a mission to unlock secrets from the deepest, darkest parts of the universe.
We can actually see light that was emitted more than 13 billion years ago. We're literally traveling in time.
It took so much ingenuity, collaboration, and dedication to design and develop this telescope. I can't wait to see what we discover.
Being a part of something bigger than yourself, that is really why I did this.
It's time to go behind the wings. This is going to be cool. I'm Myrna James. I'm a science journalist specializing in all things technology. Here at Wings Over the Rockies Air and Space Museum, we transport the magic of space to you right here on Earth. Today we're traveling through space and time alongside the James Webb Space Telescope, which is the most capable telescope in the cosmos. Using infrared technology and a revolutionary segmented mirror, Webb can gather 6 times more light than the Hubble Space Telescope. The Webb is uncovering how the universe was created and is answering questions so profound we didn't even know we had them. With the ability to observe galaxies more than 13 billion light years from Earth, get ready to travel through time. Webb launched in 2021, but the idea was sparked more than 20 years ago at NASA's Goddard Space Flight Center.
It's human nature somehow to be fascinated by space in our place in the universe. So I was taken by that just like anyone. When I started on the Webb in 1997, there were just a few of us. It was just an idea, but in front of us was to figure out how do we build something that could actually work. The Webb mission was conceived in the late 1980s, early 1990s to connect the dots between the achievement of NASA's COBE satellite, which showed us the oldest light in the universe. Around the same time, the Hubble Space Telescope was launched.
1, and liftoff of the Space Shuttle Discovery with the Hubble Space Telescope, our window on the universe.
And it took its deepest image of the cosmos that it was capable of doing at that time. And that deep field image, it looked back in time to a point when the universe was about 1 billion years old. The epoch that COBE saw, the universe was a few 100,000 years old. And so between those two epochs is a mysterious, poorly studied epoch that was referred to then as the cosmic dark zone. And it's of great scientific interest because that is the point in the evolution of the universe when the first stars and galaxies formed. The answers to all our questions are in starlight, and we have to be clever enough to extract that information.
In order to create a telescope that can see further back in time, NASA needed to invent new technology that could gather light from some of the first stars and galaxies in the universe. But first, they had to overcome the challenges that plagued the earlier space telescopes. Hubble, for instance, required hands-on human repairs.
A lot of people today don't even remember, but when the Hubble Space Telescope was launched, the primary mirror actually wasn't quite the right shape and could not focus light properly.
A significant spherical aberration appears to be present in the optics.
There was actually multiple repair missions and upgrade missions for Hubble. The very first one was really to fix the blurry vision, and then from then on in we were really upgrading the instruments. John Grunsfeld was an astronaut who helped to upgrade the instruments.
The Hubble Space Telescope was launched in 1990. In 1992, I became an astronaut. At the edge of the telescope, which is 2.4 meters across, the shape of the mirror was wrong by about 1/40th of the width of a human hair. But that was enough to make the images slightly fuzzy. So for an astronomer, that was bad. So instead of being, a great observatory and all this anticipation, it was a sort of good observatory, or maybe a little less. As an astronomer, going to the Hubble Space Telescope is kind of the holy grail of an astronaut's mission. I had the, unbelievable fortune of being able to go up 3 times to the Hubble and do all kinds of repairs and upgrades to the telescope, such that now Hubble's coming up on its 33rd birthday on orbit, and everything's working, and we're still doing incredible science.
So you were actually able to get inside the telescope here?
Yep. Now clearly this is just a model. The real telescope is 5 times bigger, about the size of a tour bus. And what you can see is that the telescope has handrails that we could use to climb around the telescope, but more importantly, it was designed to be modular, to be fixed, not only to put in new electronics, but to put in new scientific instruments. And so we were able to open these doors on orbit. I was able to climb inside the telescope to take out the old scientific instruments and put new ones in. And so you can see this opening was big enough even for my spacewalking partner, Steve Smith, who's about 6'2", in his spacesuit to fit inside.
So you did 8 spacewalks. Does it ever get old?
I wondered during training whether I would ever get tired of getting into the spacesuit and going into the big pool we call the neutral buoyancy laboratory. I've spent hundreds and hundreds of dives in the spacesuit practicing, and even that's not old. 8 spacewalks, everyone is just spectacular and magical. I was on the end of the robotic arm, moving back towards the Hubble Space Telescope, when all of a sudden I thought, is this real? I just can't believe that I'm here out in a vacuum in my spacesuit with the Hubble Space Telescope orbiting the Earth, going 17,500 miles an hour. It was kind of silly, but I just reached out with my index finger, and touched the Hubble to make sure it was real. And then, of course, it was, all work from then on.
So the ability to upgrade the Hubble on orbit is one reason that it's still so productive and still up there after 33 years. And that's not true about the Webb telescope. It's actually about 1 million miles out.
The James Webb Space Telescope is an infrared observatory. That's light from heat. And so we have to put the James Webb Space Telescope really far away from the Earth so that it wouldn't see the Earth's warmth. But that has a downside. It's too far away. It's 1 million miles from Earth. So the James Webb Space Telescope is high stakes that we can't go fix it. And so a lot of effort was put into making sure that it would work the first time. It's going to be amazing what we find out. But I think the biggest discovery from the James Webb Space Telescope is probably going to be the answer to a question we haven't thought of, something we truly discover that we never knew about.
What did it take to build the most powerful space telescope? With any project as ambitious as the Webb telescope, it takes thousands of people and many, many years.
For some of them, their entire career was riding on its success, and it actually went perfectly. Webb was primarily built, engineered, and designed at Northrop Grumman Space Park. The components were manufactured in laboratories across the globe, then were sent back to the Space Park campus for assembly.
The telescope itself and all the components came from different places across the U.S. and across the globe. And over behind me, that's where we did all of the engineering work to come up with the design, to come up with the ideas of how we were going to put it together, etc.
So Charlie, why are telescopes so important?
What made Galileo think he needed to make a telescope is to go see the things that we can't see with our naked eye. So we call it a telescope, but it's so much more than that. There are unbelievable quantities of materials that went into that telescope. from all around the world. Exotic materials that are really lightweight, some that are very hard, very stiff, all kinds of different materials that engineers used to put together the telescope. And it took millions of hours to design it, build it, test it, and get it ready for launch. I spent about 20 plus years as an engineer working on the telescope. Now it's time for the scientists to use it for 20 plus years, to make new discoveries, to find out things we don't know yet.
Normally in a project, if you count up the number of miracles that have to occur, if you get above 1, you're in big trouble. On the Webb, we had 10 technologies that we had to invent just to make our concept doable. We realized that we had 2 enormous problems that almost stopped the project dead in its tracks. This big mirror was bigger in diameter than the biggest rocket. That was problem number 1.
This mirror was so big, it couldn't even be launched in a rocket. It has to unfold and deploy in space.
That's right. So Webb's mirrors are huge. They're 6.5 meters. And so the fairing that we can launch from are about 5 meters. So they're, just a little over 1 meter too big. So what we had to do is fold back 2 sections, one side on the left side, one side on the right side of the mirror, so that they can fit into the launch vehicle, kind of standing straight up and down.
Problem number 2 is that to build an infrared telescope, the telescope has to be very, very cold, because everything above absolute zero emits infrared light. If we didn't make the JWST cold, it would be blinded by its own infrared emission. How cold do we have to make it? Really, really cold, almost minus 400 Fahrenheit. The JW Sunshield has an SPF of more than 1 million. If you had it on the beach, you would be very well protected, and it enables the Webb to achieve this low temperature.
Most telescopes have a sun shield of sorts. What you're probably more familiar with are barrels around a telescope. That eliminates light from entering the telescopes that's not exactly on axis. That's what the sun shield on Webb was trying to do. And so the way that it works was, if this light over there is the sun, and I want to look at the dark of space, the sun shield was always shielding the light from the telescope, so my eyes in this case, so that I never see the sun and I can look the other direction into the darkness to look at the first stars and galaxies.
From its sun shield, which is the size of a tennis court, to the primary mirror, which is 21 feet in diameter, the Webb telescope is an engineering marvel.
Engineering is an empirical science. You have to build prototypes, test them, see what went wrong, build more prototypes, and so forth. And on the Webb, we were able to do all of that. One of the things that makes our work difficult is that we have to work in these very, very clean environments, wearing special garments. And this is one of those clean rooms. This is really one of the largest rooms like this in the world. You can see the people are wearing these white suits, called bunny suits, and that's because the dirtiest thing in these rooms is the people. The number of people that can be in the room at any one time is limited. It's cleaner than a medical operating room. This whole brown wall is a giant HEPA filter. So the air is constantly flowing horizontally in this room through that filter. The goal is to remove every single particle in the air that can get into the hardware.
The James Webb Space Telescope is not like the Hubble, which could be repaired in orbit, because it's 1 million miles out. When the scientists launched Webb, they had one shot to get it right. So they implemented, of course, extensive testing before it ever left the ground.
The testing is as important as the flight, and so it becomes a constraint on the design. Every element of design we have to include how will we test that? What hardware do we need to test it? We call it ground support equipment, or GSE. So this is one of the payload areas at Goddard where we're testing spaceflight hardware. And much of the testing we do is done in space simulation chambers that simulate the vacuum and temperature of space. And so these large objects are space simulation chambers where spaceflight hardware is being tested, as we speak. These are giant vacuum chambers that simulate the vacuum and temperature and overall environmental conditions of space. The Webb science instruments were tested here for many, many months to ensure that they would work properly in the Webb mission. And so to do testing, we have to simulate the environment as best we can here on the Earth. In addition to making sure that the hardware will work in space, we have to make sure that it can survive the rocket flight into space. So we typically have to simulate that as well. And these big steel doors are labs that contain giant vibration tables where we will put the payload on the vibration table and shake it to simulate the rocket flight to space. And we were able to do all of the testing that we needed to do to be confident that this enormously complex thing would actually work.
Once it was built, the big question was, can it successfully be launched?
Being in the Mission Control Center with 100 other people that had also poured their hearts and souls into this telescope, the launch was nerve-wracking, to say the least. There still were some risks. You know, we had a lot of single-point failures to overcome. It was also very celebratory because we did have a lot of confidence in our partners at Arianespace to get us up into orbit safely.
From Jean-Luc Voyer, all systems are go. We're inside a minute now, and the command will be issued to ignite the solid rocket boosters. The James Webb Space Telescope will be on its way. And we have engine start. And liftoff. Décollage, liftoff from a tropical rainforest to the edge of time itself. James Webb begins a voyage back to the birth of the universe.
Back in the Mission Ops Center in Baltimore, we were kind of like, okay, get to work. It's now our time. So we still had 6 more months of deployments and commissioning to get this thing to do what it's now doing and exceed expectations. The successful launch, that was just the beginning. And now we've turned it over to the science teams to find out what they can with our data.
There's no one better to talk to about what goes on with this telescope than Kenny McKenzie.
I had an 8th grade social studies teacher. Her name was Krista McAuliffe. She perished in the Challenger disaster and kind of motivated me to enter the space business. I entered in 1984. I've spent a lot of time with a lot of different missions, but beyond all that, this is the most exciting one so far. Basically, we're on the campus of Johns Hopkins University. This is the Muller Building. It's the home of the James Webb Science and Data Processing Center and now Mission Control for James Webb. During the commissioning and instrument activation phase, both of these 2 rooms are completely full with probably 100 engineers at any one time.
So in this room is where the deployment of the mirrors was commanded, really.
We conducted all of the deployment activities from solar array deployment, which was the primary and most crucial deployment that we had to do for us to have power. So the solar array has to come out. If you don't have a solar array, your mission is basically done. So that was a very exciting, very positive start to our mission.
What was the mood in the room at that time?
It was very, very nervous, of course, as you would fully expect. People were on their feet. Everybody had a job, and we all worked very well together, and we were able to deploy it perfectly.
And we have a fully deployed JWST observatory.
Yes.
After 30 days, we were elated. I mean, we were tired, but we were elated. We had another 5.5 months to go with all the instrument commissioning activities, but we felt comfortable that all the subsystems were working, the communications were good, beyond all reasonable expectations, worked as, as designed.
That's incredible.
It was very incredible.
It's really just the beginning of a whole new era.
We're still a baby. We've been up on orbit for just over 12 months. We continue to explore and develop and uncover amazing items. It's a good time to be part of the Webb program.
Okay, this is the real-time screen of what's happening.
Yeah, depicted on this screen basically is the view of the observatory as it sits in space. We use the Deep Space Network, which is 3 different complexes located geographically around the world. It gives you a visualization of where this observatory and the telescope are pointing.
So scientists from all over the world are so excited about this data. How do they use it?
For each program, it looks at a different part of the sky, and the longer you stare, the more light that you're actually going to receive. Some of these observations may be, in the order of 2 or 3 hours, and some are up to 20, 25, 30 hours.
So where are we in the process of getting this data?
We're at the tip of the iceberg. We were very successful in conserving fuel, so we anticipate having a 20-year fuel budget, which will allow us to do imaging and so forth, as long as the instruments are able to allow us to take data.
Over here is actually one of the main places that we align the telescope from. And up here you can see, we call it the commissioning flow. These are all the steps that we did to align the telescope over about a 3-month period. As we went through the entire process, we X'd them all out. And there's one particular step in the middle there where we got the very first images that were focused, and that's why it says champagne, because after all those years, that was the moment we knew we built the right telescope.
Wow.
So we were
the moment to celebrate.
The moment to celebrate. When you look at it from the 20,000-foot level, things went amazingly well. Probably better than any of us expected. And the thing that was really special is that when we got to the final performance, it's almost performing twice as well as we expected.
So why is this so important to you, Lee?
These kinds of missions, these missions that bring back amazing images and help us understand how we got here, they inspire young people. And I think that's what it's all about. It shows what human beings are capable of doing when we work together. And maybe that's a lesson that we can apply to other challenges that we have here on Earth.
It's so inspiring for science in general.
We could be learning new physics that then relates to what's happening here on the Earth. We still have a lot of the universe that we don't understand, from dark energy to dark matter, and the Webb telescope will contribute to that as well. It's been a little over a year, and of course, we've come really far in terms of how well it's performing, getting it operating. But from a science perspective, we're really just getting going. From now on, every field is a deep field, and that's sort of the way it's been. This is going to be a very exciting few years, maybe some of the most exciting few years in the history of understanding our universe.
The telescope is built, deployed, and the science is rolling in. The data is epic. So you were the principal investigator for that first batch of images. How were those images received by the public?
It was a very interesting process. It took us years to prepare for this. And of course, we had this task of demonstrating to the world that this $10 billion observatory was worth it. Right? That we could produce something that anybody would look at and say, wow, this gotta be making amazing science. And that included producing these beautiful color images. And so, of course, we were worried about that. We were nervous. I mean, can we actually do that? We didn't know what the images would look like. Like, this is such a new observatory with such new capabilities that we could try and predict what we would see, but we couldn't really predict it. And all the data that the observatory takes really is the property of the world. And so eventually it all becomes public, and anybody can download the data. You don't even have to be a scientist to download the images and look at them.
So Klaus, you saw the first images as they were coming down from this telescope.
Right, I saw the first color images, the first science images that we took, the ones you've seen. For example, the cosmic cliffs or the first deep field. The primary feeling I had was really of loneliness, because the first image came down, it was sort of late at night. I didn't download it here in the office, I actually downloaded it in my basement at home. So I was sitting there this evening in my basement all alone, and I was looking at this image of the deepest view of the universe that anybody had seen. And it was profound loneliness because I couldn't share it with anybody.
So the colors are gorgeous. And what do they mean?
So the colors mean something physically. So when we pick a filter, what that does is it actually picks out a signature of a specific molecule or a specific element. So here I have pulled up an image that uses a filter that sees organic molecules. So 4.6 billion years ago, our solar system looked like that. All this stuff around you see here, that's the organic material that we're made of that ends up on the planets in there.
It makes me feel like I'm part of the universe.
Oh, we're very much part of the universe. Right, as Carl Sagan said, we're the universe's way of thinking about itself.
So we're starting to get this data now. Is it creating more questions than answers?
Oh yes, it's creating more questions and answers, absolutely. And I think that's where we want to be, right? If we are starting to run out of questions, we're not doing something right. That's not how science works. We want to answer questions, but we want to make more questions than we have answers. There'll be future telescopes because we need that to answer all those new questions we have.
You and so many people have dedicated their careers to this project. How does it feel now that it's up and it's running so well?
It's performing better than expected across the board. And that is true in terms of its lifetime expectancy. Its optical performance is about a factor of 2 better than the expected performance. How stable it is when it looks at an image is about a factor of 7 better than expectations. So yeah, it's incredible to see how well it's performing up there.
One of the great things about science is that we learn new things. And often those new things that we learn overturn a previous idea. That's certainly going to be the case with the James Webb Space Telescope. It sees the universe so much more clearly, so much deeper. I think there's some big surprises in store that James Webb will give us.
The Webb is giving humanity its very first high-definition view of the infrared universe, and the view is fantastic.
The great thing that I took away from Webb and being part of this project is helping to build something that fundamentally contributes to humanity's knowledge.
My dream is to continue trying to do hard things. I love the idea that I've gotten to work with a team that has enabled the science classes that my kids will take aren't going to be the same science classes I took. That's very exciting.
Building the first segmented space telescope, this is sort of like landing on the moon for telescopes in a sense that it's the first of a kind. But a segmented telescope is scalable. We can build bigger and bigger. And then after that, we can think about assembling telescopes that are made up of segments like this. And that's what we're going to need someday if we want to take an image of a planet just like Earth around another star in high definition. The Webb telescope is the first step on that journey.
With its successful launch and deployment, Webb is expected to support scientific observation for about 20 years, unveiling the secrets of the universe, one discovery at a time. All of us at Wings Over the Rockies Air and Space Museum look forward to uncovering more mysteries beyond our planet and sharing them with you. We'll see you next time on Behind the Wings.
We're getting an inside look at the most advanced fighter of them all, the F-35. Can we go see the real jet?
This is the most capable, the most advanced fifth-generation fighter, and its capabilities are unmatched.
You see everything in an F-35 because the sensors are so advanced. You have stealth and other defensive systems on the aircraft. For the most part, nobody sees you.
I can't wait to see how these are built.
The production system set in place in this most powerful building in the world.
When you think about all that's out there, the F-35 is the central node in that. It's the quarterback out on the field.
From the factory to the field, let's go see this thing in action.
The capabilities for what we can do, they're light years beyond where we were at just a decade ago.
This is going to be cool. It's time to go behind the wings. I'm Tracy Lauderette, Colorado's First Lady Fighter Pilot. I'm at Wings Over the Rockies Air and Space Museum in a historic World War II era hangar. Today, we're going to the cutting edge of aviation alongside the F-35. I cut my teeth on the F-16, and while it will always be my favorite aircraft, the F-35 is transforming the world of aviation and land and sea defense in ways I never could have imagined. Get ready for takeoff. The F-35 is not your average fighter jet. It has the most advanced sensor suite of any fighter jet in history. Its integrated helmet technology crunches data in real time. This flying marvel is powered by the most powerful fighter engine in the world, the Pratt & Whitney F135 engine with about 43,000 pounds of thrust. So it can fly faster than the speed of sound at Mach 1.6. That's about 1,227 miles per hour. There are 3 versions of the F-35. The most common variant, the A model, is flown by the Air Force and used on conventional runways. The B model can hover and land vertically, and the C model is made for landing on aircraft carriers and has a tailhook. The F-35 first flew in 2006, entered service in 2015, and today is utilized by the U.S. Air Force, Navy, and Marine Corps. To date, 9 countries around the world operate the F-35 on their own home soil, and it's operated on 26 bases around the world. We're here at my alma mater, the United States Air Force Academy. Today, we're here to learn about our 5th generation F-35 Lightning II fighter aircraft. So we've both flown 4th generation fighters. For you, the F-15 Eagle, for me, the F-16, which I absolutely loved. But I'm dying to know, what's so special about the F-35?
The F-35 is far and away our most technologically advanced fighter. It's the only 5th generation fighter that is continuing to come off the production line. It represents a generational leap in technology, capabilities, and capacities. And it's all about lethality and survivability. Lethality, i.e. you can go out and fly an aircraft and achieve your mission objectives, whether it's dropping a bomb or launching a missile. And survivability, if somebody's trying to stop you from doing that from the ground or from the air, you know that you're going to be able to come back from that mission without having to take a ride in a parachute on the way down.
Nobody wants to take that silk ride. Can you tell us a little bit about how they're different from the older generations to what you found in the F-35?
Yeah, so the Air Force has over the years kind of described or binned their fighters into generations. 1st gen, 2nd gen, 3rd gen, 4th gen, 5th gen. The way that I view them is the 1st generation was really our first frontline fighters at the Air Force field. I think like the F-86s in the Korean War. 2nd generation, now you're kind of talking our Century Series aircraft, you know, the F-100, the F-104, the F-105, kind of the early Vietnam era. And then our 3rd generation fighters were the more advanced, multi-role, supersonic with radars, kind of think the F-4 and the F-111. 4th generation fighters are kind of our existing but older portion of our fleet, the F-15s, the F-16s, the F-15E models. And then the 5th generation fleet is typically described as the F-22s and the F-35s.
What role does the F-35 play in deterrence?
Nobody wants to get into war, right? That is like the worst case scenario. So if we can deter our adversaries that are even considering going into a conflict with us, and they know that we've got a fleet of F-35s, a fleet of F-22s, and a wide range of other capabilities and capacities to back them up, hopefully that makes them less inclined to cross a line where we get in a shooting match. So deterrence is without a doubt the #1 imperative, but if that all fails, we've got the muscle to back it up if we need it. A couple of key components to specifically the F-35, when you think about 5th gen, stealth is certainly an absolutely critical component to a 5th generation fighter. So you can operate with this concept that we call tactical impunity. So you can prosecute your attack, go out and accomplish your mission without being at threat or at risk or distracted by an enemy that knows where you are, and when they know where you are, they can find a way to distract you, or even worse, target you and shoot you. And then it's about integrated avionics and advanced sensors. And the F-35 has all 3 of those, and they're getting better with every single one that we get off the production line.
Now that we've learned a little bit about the technology behind the F-35 and how we've advanced to this 5th generation fighter, let's go check out how it's built. We're here at Lockheed Martin's jet production facility in Fort Worth, Texas. This historic plant has been producing airplanes since World War II, and today we're entering the production facility to get an inside peek at the most advanced fighter of them all, the F-35. This is the F-35 assembly line, made up of 300 workstations, 50 robots, and 4,000 humans working together along this mile-long stretch. This place is enormous.
This building has been here for many, many, many decades, building all kinds of aircraft. Today, we're building the F-35 here. When I first started, we were building the F-16, and in fact, a little bit center fuselage for the F-22. But the factory, even though it's the same outside walls, a little over a mile long, it's very different inside today. We're building at an incredible rate we've never seen before in a fighter aircraft. There's a tremendous amount of technology on this floor. 90,000 fasteners in every airplane. So if we had somebody installing 90,000 fasteners, it would take a lot of time and frankly may not be so repeatable. So we bring robots in, They do installation of these fasteners, they do coating work for us, and it frees up our mechanics to do really the craftsman work.
So it's a little different than the Rosie the Riveter days. For the amount of work that's being accomplished every single day, you walk in and you can practically hear a pin drop in here.
It is pretty cool, and that's the change, the combination of automation and technology combined with skilled craftsmen.
Could you talk a little bit about some of those special characteristics that make the F-35 so powerful?
I'll start with low observability. What that means is it gives us the opportunity to get into the enemy airspace without them seeing us, without being detected. And it's a very fundamental feature of 5th generation that the F-35 has mastered. And frankly, the F-35 has been learning from those that came before it. Probably one of the most unique things that the F-35 brought is the ability to communicate not just to other F-35s, but to all the other players in the battle space, to be able to share information from an F-35 to another F-35, or to a ship, or perhaps bringing it from a satellite. So when you think about all that's out there, the F-35 is the central node in that. It's the quarterback out on the field. The jets that are rolling off the line today, in a couple of years, they'll be new and different capabilities, and we've been able to accommodate that. As the threat advances, we're going to stay in front of it.
As we make our way down the line, these jets are really starting to take shape. Along the way, parts and components are added like building blocks. Every aircraft is made to order and bears the flag of the country that's adopting it. About 150 F-35s roll out the door every year. So Eloy, we're here in this beautiful production facility where these babies are made. I gotta hear a little bit more about just how are these aircraft built?
The production system set in place in this most powerful building in the world. There's lots of teams that come together. We're constantly in continuous improvement. Each section that it comes in, you get to see the beauty of it come together until we reach the final end and we do the engine install at the very end. And then when it comes out to the paint shop and we finally get a beautiful bird that you see in the sky.
I also heard that you're not the first in your family to work in this plant. Can you tell us a little bit about your parents?
I'm actually the 2nd generation to build such a prestigious aircraft. My parents were on the F-16 program. So I was a product of this kind of environment. So it is a very prideful thing to follow in their footsteps and actually be a part of the process they were for their generation. And today's warfighter is far beyond anything that I've ever seen on the entire planet. We do have the air superiority around the world.
Eloy, does this place ever shut down or do you guys operate 24/7?
This aircraft cannot be built on one shift. We have over 4,000 people working round the clock to produce this aircraft.
Each jet spends about 18 months in production until the newest F-35 rolls off the line, ready to turn and burn on its first flight. We've made it to the end of the line, and one of the people who gets to test the F-35 on its first flight is Monessa Balsizer, call sign Siren. She's the first female F-35 production test pilot, joining an elite group of female F-35 pilots who came before her. As Colorado's first lady fighter pilot, I'm so excited to meet another first in her field. So the F-35 takes center stage today, but what really brought you to Lockheed originally?
I actually joined Lockheed Martin as a F-16 engineer because that was my background and what I knew for so long. And then I got lucky enough to be asked to fly for the company. I eventually started off in the F-16 and then got offered the job to start flying the F-35 as well. I probably have the best job in the company. So yeah, welcome to the F-35.
So you get to be the first pilot to get your hands on this jet. It comes off the production line and they hand it over to you. Can you tell me a little bit about what that's like?
Literally, it's like a new car for me. New smell, the buttons are nice and crisp. The production line technicians, they did a fabulous job of putting the jet together, and then it gets handed into final assembly, and then the maintainers bring it out here for us to climb into the cockpit. What you see in front of you is the F-35A model. It is the cornerstone of 21st century security, and it is a force multiplier because it does so many roles and its capabilities are unmatched. Hidden in this glass area located in the front of the F-35 is what the pilots call the EOT system, or the electro-optical targeting system. That is now internalized into the F-35, makes it part of stealth, and then also is a key feature in our sensor fusion. So it's all compacted into this one area. But the great thing is this one sensor talks to everything around the jet.
So thanks to this piece of technology, the jet really becomes a thinking part of the crew, right? It's like you're flying a giant computer.
Absolutely, and it's just one of the many things around this jet that provides that sensor fusion or flying computer that you always talk about.
Can't fly the real jet, but let's go fly the sim. So no two-seaters out there for me to fly in the line, right?
Nope, sorry,
All right.
just single seats.
All right, let's do it.
It's like you've done this before.
Oh, it's like home. I feel like everything I could possibly want to see is available to me all at the same time.
It's a different mindset for
Right.
F-35 pilots. They manage the battlefield and they manage the battle space, sharing data, air and ground.
So flying the jet itself is supposed to be relatively simple, so you can do all that.
They made it easy so that the pilot can look inside
Right.
and manage the sensors. The fly-by-wire system allows the pilot to really almost go hands-off.
Yeah.
Super stable aircraft,
Wow.
and now touching inside to manage everything. Generally, you'll take off, depending on your configuration, looking about 150 knots, pull back on the stick to about 10, 13 degrees nose high, and then you're pretty much letting the jet fly off the runway, getting your gear up. There you go. Felt the afterburner there.
This
Easy.
thing is so easy to take off. Even I could fly it after all those years.
It comes back to you though, right?
It does. It's like riding a bike. It's like flying a jet.
So one thing I wanted to show you was our automated ground collision avoidance system. It saved 13 pilots' lives.
Yeah.
Lockheed Martin pilots were saying we need to get this in the F-35s.
That's like an autopilot that takes over
Absolutely.
and hopefully keeps you from crashing. That's how it saved all those lives already.
The AGCAS system, what it will do, it will take control of the flight controls if it feels that you are within 3 seconds of hitting the ground. And that's based off of your altitude, your airspeed, your attitude of the jet. It will use the necessary amount of G's to get you flying straight and level. So you see chevrons come and...
Wow. What an incredible piece of technology. I'm so glad that it is in every one of the jets that are leaving the line. So are those 13 people that are alive today because of it.
Oh yeah.
What an amazing day getting to see the jet up close, but duty calls.
Well, thanks for stopping by, Lockheed Martin.
All right, I'm out of here.
Let's go.
From the factory to the field, let's see this thing in action. We're here at Marine Corps Air Station, Miramar. We're gonna hang out with an operational F-35 squadron today. Squadron VMFA 314, home of the Black Knights, and the only Marine Corps squadron to fly the F-35 C variant. They're hosting us for the day and giving us a day in the life of an F-35 pilot. Snooki, everybody wants to show up, hop in the jet, and go turn and burn and have some fun, right? But there's a lot more steps involved than just showing up and flying.
Yeah, absolutely.
Can you walk us through?
I wish it was that easy. So I tell everybody it's not just about the flight itself. You got the preparation on the front side. So that's all the mission planning that you do with computers nowadays upstairs. And then you actually got to talk about what you just planned. So that's called the brief.
It's time to go into the flight briefing room where we're going to cover the details of today's mission. Come on. Briefings take place before and after each flight and are at least an hour each, depending on mission complexity.
Mission overview will take off out of here, head out to the R2301 West, knock out our high aspect BFM just amongst ourselves. 1125, the 401 F5s are going to take off. We're going to knock out our dissimilar BFM for the second code for today. What this could look like for you as you go vertically into this merge and you misassessed his energy. Maybe you thought he was slow and couldn't come up to meet you, right? Say, for example, you decide to go up, exploit the vertical, and you realize that he's got energy to come up and match you. If you were to take lead pursuit in this case, sure, it's going to probably achieve a weapon solution faster, but you also realize you're giving him a blue sky background and the ability to pull forward on his canopy and achieve a shot against you. Any questions on what we're going to do today? No, sir. All right, let's get dressed and go.
So that's the flight brief. It's time to suit up.
All right, so yeah, we're here. This is where we have all of our flight gear. We have the jacket with all of the survival gear on it, as well as the G-suit, and then this is where we keep our helmets.
Costing hundreds of thousands of dollars a piece, each helmet is as specialized as the jets themselves. Fitting a helmet to a pilot is a 2-day fitting process that involves pupil measurement and can be affected by slight variations in hair length or even weight. The helmet nearly becomes an extension of the pilot's body.
You put this helmet on. It's sized, laser cut for your head, And then once you're wearing it, this will connect to the aircraft on the right side of the G suit. There's no physical heads-up display in the cockpit. It's obviously just in the helmet here. With the display visor down, that's where all of your symbology will be combined, and then we have an outer visor that protects from the sun as well. So one of the interesting things about this helmet is you don't ever fly with night vision goggles. It's always fully integrated. So if you have a mission where you take off at night, land after sunrise, or vice versa, you don't have to take any extra equipment. You literally just lift the dark visor up and everything works perfectly.
You're doing more than just flying your own jet. I mean, even unarmed, this aircraft has so much more ability to integrate the force.
There are a lot of aircraft that carry weapons and have their own sensors, and the F-35 is no different, except that the sensors it has have the ability to share a massive amount of targeting data with everyone else who's airborne or on the ground. Yeah. So what we are is we're effectively a node in a much larger web of systems, and our presence in a fight, even without weapons, we have the ability to allow other aircraft to participate and be more survivable and lethal in ways that they would not be if the F-35 were not there.
The thing that really strikes me is the fact that there's only one seat in these aircraft. So what are you guys doing to take a pilot from the simulator to their first sortie, which is also their first solo in the F-35?
The way we handle that is actually through a little bit longer ground school than you're probably used to include more simulator training. When you have your first flight, there's an instructor in another aircraft chasing you. So you do have that safety net initially, but it is an increased amount of trust that is given in F-35 pilots initially to learn the aircraft and fly it by themselves. But we've adjusted to that as a community. And from that point, it's very similar to any other fighter aircraft training you would go through, where you go through initially familiarization, and then you start to introduce more complex types of flying, formation, night flying, air to surface, air to air, and then typically carrier qualification, where you go out to the ship both day and night and take arrested landings as well as catapults in the F-35C. That's the culmination of your ability to fly the aircraft, and that's really from start to finish how that all works.
So you just got back from deployment, working with our coalition forces on the other side of the world. Where were you, and how well does the F-35 integrating out there in the real air battlefield?
The aircraft's performing very well. The range, the sensor performance, and the ability to integrate and share information with the 4th gen platforms. The F-35 really proved its worth where we were, whether that be the Philippine Sea, East China Sea, South China Sea, etc. We were able to meet higher objectives for just really being present and showing what an air wing of the future looks like with F-35 integrated. It's very rewarding as well to really be at the tip of the spear, as an air wing mission commander going out and planning whatever type of exercise we were doing. To have F-35 really at the forefront of that and controlling the whole exercise was absolutely the most fulfilling thing I've done so far in my career.
Our kids all wanted to fly the F-16 like mom and dad, but after everything I'm learning about the F-35, I gotta say, they're cleared hot if they want to follow into the F-35 world. It's so impressive, and as the airplane continues to evolve, I can't wait to see where the F-35 takes us. Snooki, you're the commanding officer here at the 314th. You're in a Marine Corps fighter squadron. You deploy on an aircraft carrier, yet you train here at Miramar. Can you tell me a little bit about that?
Yeah, absolutely. And we're a pretty unique squadron within the Marine Corps, actually the only F-35C squadron. For us, the F-35C was designed for an aircraft carrier. However, being Marines, we kind of alternate between deploying with the Navy on the carrier and then land-based operations as well. So when we're focused on land-based operations like this summer, we're talking about operations out there in like the South Pacific Islands in Australia, and really getting out there and working with our allies and partners. It's about training for real world operations. So we train like we fight.
So the pilot just completed his walk around, hopped in the cockpit, did some final checks, and you can hear he's cranking up the engine. It's time to go fly. These guys are getting ready to go fly high aspect BFM. Basically, they're gonna dogfight, and they're probably gonna be up in the air for about an hour and a half. Man, I am jealous. Fights on! this thing fly. The F-35 is such an amazing aircraft. The F-35C model is especially cool. It's the biggest one of all three variants. It's used for landing on aircraft carriers, and it has a ton of range. Let's go talk aircraft carriers. So we got F-35s landing on aircraft carriers. Why do we put them on the boats to begin with?
So the F-35 Charlies are on the aircraft carrier because we are the 911 response to the world in crisis. The F-35 plays such a key role in that is because with the technology we provide, we can connect everybody from legacy in the air, in the ground, and give them a much bigger and more detailed picture of what we're facing so that they can complete their missions.
What does the flight deck controller do on the aircraft carrier?
So as a flight deck controller and FDC, I am the middle person that talks with the dog in the tower so that way we are maneuvering, because on the flight deck you have about 40 to 50 aircraft at one time maneuvering in a very small area, which is about the length of 3 football fields. So you have 3 football fields with 50 plus aircraft all moving, all turning at the same time. So my job is to make sure that everyone is safe, making sure that the dog knows where my aircraft are compared to the rest of the squadron.
What's it like when the airplane comes in to land? Like, how does that look?
It's called a controlled chaos. It's a controlled chaos for a specific reason because of the chaotic mindset of everyone moving all the aircraft around. What stands out with the F-35 Charlie compared to the Alphas and the Bravos is that we have a tail hook which catches an arresting cable and the back end of the aircraft carrier, which assisted to get to that stop when it comes to land.
I think landing on the aircraft carrier has got to be one of the most impressive things I've ever seen. I would love to experience that someday. But you know what is more impressive to watch is the B model with the short takeoff, vertical landing. I understand you have some experience with that one as well.
I do have a previous experience with the F-35 Bravo, which is the Marine Corps' replacement variant for the AVAB Harrier. So they operate off of what we call an LHD, which is a smaller size carrier which holds helicopters and the F-35 Bravo. So with the rest of the branches, Air Force and the Navy and the Marines, working together with the F-35 program, it does help everyone integrate with one another.
Where do you see the future of the air battle turning?
Fast forward 10 years, I see F-35s, F-15Es and EXs, F-16s, and partner that with the B-21, and you're going to have a heck of a force.
When we were out there on the battlefield, there were things that we did that were unprecedented, that they had never seen before. And what we look at 10, 20 years from now is going to be a different and even more effective F-35 ready for the future fight.
When I think about the legacy of it, it's enabling others in the fleet, and from a relationship across the globe, all the allies coming together. It does represent the baseline of our 5th generation fighter aircraft.
I think the F-35 is not only the most capable 5th generation aircraft that we have now, but it's also the most capable aircraft for the future.
It was so inspiring to learn about the incredible technology behind the F-35 and how it will protect our country and our allies. From all of us here at Wings Over the Rockies Air and Space Museum, we're looking forward to taking you on more adventures, exploring aviation on our planet and beyond.
The Artemis program is led by NASA along with 6 partner agencies. The goal is to return humans to the moon and establish a sustainable presence there, preparing us to develop the necessary skills for future missions to Mars. It sounds like science fiction, but it's happening right now.
We're starting to break the bonds from our home planet, just like we were breaking the bonds from gravity and being able to take flight.
A new chapter in space exploration is about to unfold.
The launch of Artemis 1 is a new beginning for discovery, for our country, for our species.
We have this one single planet that we have. What's beyond there? Where else can we go? Can we live on Mars?
By establishing a sustainable presence on the moon and developing new technologies, Artemis is paving the way for future missions into deep space. Get ready for liftoff. It's time to go behind the wings. I'm Myrna James. I'm a science journalist specializing in all things technology. We're here at Wings Over the Rockies Air and Space Museum in Denver, Colorado. Today, we're going into deep space, with NASA's latest human exploration program, Artemis. There's a lot to explore in this one, but before we dive into the Artemis program, let's take a look at how we got here.
We choose to go to the moon in this decade and do the other things, not because they are easy, but because they are hard.
Apollo was the first ever space program to bring humans to the moon, but it was a huge technological challenge. The Apollo 1 mission began in 1967 and sadly resulted in the loss of 3 astronaut lives during a test. By 1969, Apollo 11 brought Neil Armstrong to take the first ever steps on the moon.
It's one small step for man, one giant leap for mankind.
Apollo 17 was the final Apollo mission, and the program ended in 1972 due to lack of funding and risk to the astronauts at that time. At the Kennedy Space Center in Florida, it's a whole new era for space exploration.
This is the place where our species first departed the shores of our home planet. We launched our American astronauts on the Saturn V launch vehicle during the Apollo program. And they first walked on the surface of another celestial body, and they departed right here at the Kennedy Space Center. And since that time, we've continued to do incredible things. The Kennedy Space Center is an amazing place right now. It's never been busier.
Artemis 1, the first mission of the Artemis program, was a test flight for spaceflight hardware and software. It was uncrewed, which means, of course, no one was on board. It launched in November 2022 from Kennedy Space Center.
The launch of Artemis 1 is a new beginning for discovery, for our country, for our species. We're going to learn things that we can't even anticipate by sending our astronaut crews back to the moon to stay, to live, to learn, and eventually it'll give us the knowledge and information we need to go to Mars.
How did it feel when Artemis 1 launched so successfully?
I'll never forget driving into work that day and thinking to myself, this is the day for us. We're going to launch Artemis today. And then I got into the fine room, and at the time, I was director of engineering, so I sat with the chief engineers. As we approached the T-minus 10-minute hold, the launch director, Charlie Blackwell Thompson, giving the go for Artemis 1 launch. The ground launch sequencer, a computer program that controls the launch, picked up the count at T-minus 10 minutes. It monitors thousands of measurements, both on the ground and on the launch vehicle and spacecraft. And I'm thinking to myself, we're really going to go. And at T-minus 6 seconds, the main engines on the core stage lit up, and I could see the glow coming out from the mobile launcher. The countdown went 5, 4, 3, 2, 1.
Boosters in ignition.
And the solid rocket boosters ignited, lighting up the entire Florida sky. We've got to get that vehicle clear of the tower, get the umbilical arms out of the way. And before I could even complete the thought, the vehicle had cleared the tower. It was a fast mover.
And liftoff of Artemis 1. We rise together, back to the moon and beyond.
The Artemis 1 launch was amazingly successful. The launch vehicle put the Orion spacecraft on a precise trajectory around the moon. And after about 25 days, Orion approached the Earth at 25,000 miles an hour, re-entered the atmosphere, and with the aid of parachutes, hit the water about 20 miles an hour.
After that successful test flight, where does it go from here?
Engineers are combing over the data right now for the launch vehicle and the spacecraft, and we are making modifications to the mobile launcher. We're hardening it, making it able to withstand the blast loads, the exhaust coming out of the rocket, if you will. And we're getting ready to launch our next cruise to the moon for Artemis 2.
You can just feel the excitement here.
That's right, we're standing right here on the base of the mobile launcher. This 400-foot structure is where we assembled the Artemis 1 launch vehicle, the Space Launch System, and we launched SLS and Orion to the moon back in November. This huge structure is going to be used for Artemis 2 and launching our first cruise back to the moon since 1972. The day after the Artemis 1 launch, I came out with a couple of friends of mine, and I could feel the crunch of the solid rocket booster residue under my feet. And I looked up at the tower, and I contemplated the enormity of our accomplishment.
Artemis II is scheduled to launch in November 2024. It will introduce a 4-person crew and focus on testing human factors on the Orion spacecraft around the moon. Think about that. That will be the furthest humans have ever been from Earth. Artemis III is planned to take the next step of landing astronauts on the moon, including the first woman and person of color. To achieve the goals of Artemis, NASA is developing new spacesuits, rovers, habitats. At the forefront of their effort is the Orion spacecraft, the only vehicle designed for deep space exploration. It looks a lot like the Apollo capsule, but inside and out, it's packed full of technology that makes it safer and more capable than any of its predecessors. At Johnson Space Center, the Orion spacecraft is a centerpiece of the first crewed Artemis mission, Artemis II. Debbie, can you introduce us to Orion? It's right here.
Well, we have a suite of vehicles that can go to International Space Station and do some low Earth orbit kind of activities. Orion's unique in that it's the only spacecraft that can go to deep space. It's made up of 3 main components. So what you're seeing behind us here is the crew module. This is the only piece that comes back after our missions. But there's actually 2 other pieces that are very vital to the spacecraft. There's the service module, which actually is attached to the bottom of the crew module. It provides all of the power, propulsion, propellants. Most of the attitude maneuvers that we do during a mission are done with the service module. It's built by our European partners across 10 different countries in Europe. And then on top, when you look at pictures of Orion, you'll see a kind of a tall, pointy structure. That's called our launch abort system. So that is designed primarily for if there's an emergency either before we launch, while we're on the launch pad, or during that ascent phase. That launch abort system actually takes this crew module with the crew inside and flies it away from the emergency. So we get rid of the launch abort system about 2 minutes into flight, so we know we don't need it after that point, but it's very vital.
Orion is the cornerstone. So how does it fit into the whole Artemis program?
In addition to the spacecraft, we have our Space Launch System, which is the big rocket that we launch on. We have some ground system support coming out of the Kennedy Space Center. And then there's these other elements that come into Artemis as we fly these different, more complex missions. Starting with Artemis II, we fly just the crew on our vehicle. Artemis III, we bring in the lander, so that'll be the first landing on the moon. Artemis IV, we expand to this thing called a gateway, and we actually put a gateway very similar to a small space station in orbit around the moon. And so we can actually have more regular access to the moon and do lunar sorties from that permanent base that would be around the moon.
When it's time for launch, NASA's Space Launch System, or SLS, is a super heavy lift launch vehicle that serves as the basis for human exploration beyond Earth's orbit. Towering 212 feet tall, SLS boasts unparalleled power and capabilities, making it the sole rocket capable of sending Orion, astronauts, and cargo directly to the moon in a single mission. Giovanna, what are we looking at here?
We are looking at ICPS. ICPS is the interim cryogenic propulsion stage. It's the second stage on the Space Launch System. When you see it on the rocket, it just looks like one big stage altogether, but as you can see here, it's actually broken up into several components. You can see the liquid oxygen tank, the liquid hydrogen tank, and of course those are the fuels that mix together to ignite the engine.
It's amazing to see this up close. So you're a rocket scientist. How do you launch a rocket?
So to launch a rocket, there's a lot of complicated parts that have to come together to work perfectly to make it happen. So we'll start with them separately, have the second stage, and once we're done processing it here, it will integrate with the first stage. We'll go out to the launch pad, and every group has to come together, work together to make it happen.
So we're 4 stories up here, and this rocket is going to be so heavy. How does it get off the ground?
So the way the rocket gets off the ground is the engine's on the core stage, and once that launches, that's when ICPS gets to take over in space to get Orion to the moon. So ICPS has 2 engine burns, one when it separates from the core stage and another one later on to get Orion into the higher Earth orbit it needs to make it to the moon. We have testing and processing that we need to complete here in this facility. Once we're done, we will hand it over to NASA, and we will actually go over there and collaborate with them on their testing and even do some testing there ourselves. So we work in cooperation with them all the way up until launch.
You can't do anything on the scale that NASA does things without the team coming together. When I think of NASA, I don't just think of NASA, Kennedy Space Center, Johnson Space Center, all the different centers. I think of NASA contractors. We are NASA. All these teams working together. ICPS here at Kennedy Space Center, this is special. This represents the future of human spaceflight leaving low Earth orbit.
The ultimate goal is for people to live and work on the moon. So each Artemis mission builds upon the last to help get us there.
The interesting thing about working on human spaceflight, obviously there are many aspects. There are pyrotechnics, mechanisms, structures, things that we have to consider about the vehicle. But when you put the crew and the human element in the middle, you have to worry about the level of vibration they may see, and also how do they interact with the vehicle? How do they control the vehicle? We give them displays to monitor what's happening, and we give them controls that they can reach under the influence of both vibration and acceleration that increases as they go into space.
What kind of testing did you do for vibration?
In general, the philosophy is you want to go to the limits on the ground so you know what happens if you ever see that in flight. What I saw from Artemis 1's data, we won't get anywhere close to the levels where we're feeling like that vibration is potentially injurious, and we will be able to read those displays throughout all of the missions. You learn new things anytime you go into space. Now we add crew to the Artemis 2. Now we're going to understand how humans live in our vehicle and operate it.
So Artemis 2 is the first crewed mission for the Artemis program. Is this what the astronauts will see when they enter?
This is very much what they would see as they come across that gantry. They're 300 and something feet in the air at the top of the rocket. They'd be walking across this gantry, and this is what they would approach as far as the crew module and mock-up of the launch abort system here. And that's what they would go inside. So let's go in. This is amazing.
So Artemis 2, the astronauts will be in here for 10 days. They'll do everything in here, live, work, everything.
So on Artemis 2, one of the first things that we're doing is checking out the environmental control and life support system. So we did not fly that full system on Artemis 1. So one thing we'll be doing the first couple of orbits around the Earth before we commit to going to the moon is we'll be testing out that environmental control and life support, making sure it's all working exactly as we had planned on Earth. But this is where they would actually practice the handling qualities of the spacecraft. So on Artemis 3, Orion has to dock to the lander. And so before we do that on Artemis 3, we want to practice those rendezvous and prox operations maneuvers.
So the astronauts will be lying down. Can we check it out?
Yeah, absolutely. They'll be lying down, they'll be wearing their launch and entry suits, and so they would be strapped into these seats and ready to go. So the commander would be sitting here, the pilot would be sitting here, and behind me are the crew displays. It's not a touch screen. They didn't want a touch screen because of the proximity of all the things going on. The only thing you really see manual switches for are for off-nominal events. If the crew had to, for example, throw the parachutes themselves. You know, those things are very automated sequences, but there are some things that the crew has manual switches for in case of an emergency. You've got a rotational and a translational hand controller, so that's how they would fly the vehicle, and beautiful views out your window above.
Being in here makes me realize, like, this is real. This is not a concept on paper. You know, we're already doing it. It's so exciting. And thank you so much for showing me the inside of Orion. You're focusing on the people.
Yes.
And so where are we here?
So we are in the Orion Mission Simulator. This is one of a couple of key training facilities that we'll use to train the Orion crew members. So for Artemis 2, we'll train the Artemis 2 crew, and for future missions, the launching and flying an Orion piece of their training will happen here.
So the astronauts are learning exactly what they'll do when they're flying, so of course it won't be the first time when they're there that they've done it.
Our whole goal in training is to make sure that at the end of everything they're doing, that they and the ground teams are prepared to fly the mission successfully.
How did it feel when you announced the first 4 astronauts?
So I was fortunate enough to be in the room when they made that announcement, and it was incredible. They had almost everyone from the astronaut office present, and to see those folks get called out from that group as those 4 walked on stage, I thought, man, what an honor to get to train these folks.
Ladies and gentlemen, your Artemis 2 crew, Reed Wiseman, Victor Glover, Christina Hammock-Koch, Jeremy Hansen.
We are super excited to have the Artemis 2 crew named
because now we've been doing all this development and we have crew members come over and help us, but now to have the Artemis II crew be able to come and put their stamp on it, and we'll be able to get their feedback and help with that is just, I think, super excited for all of us that are working on Orion to actually see the crew use the vehicle. With the Artemis program venturing into deep space, that is one of the biggest challenges is how we deal with radiation. And one of our biggest concerns is how that's going to affect the crew. Not only with the exterior of the vehicle, in our crew capsule and the crew module, we have the crew get into 2 of our stowage bays that act as a radiation shelter, and that's how we protect the crew. Not just another autonomous spacecraft, it's not just another rover, it's actually a spacecraft with human beings on it. And so every day we do our design and we think about Reed and Victor and Christina and Jeremy and how are we taking care of them personally to make sure that they come back to their families.
Instead of talking in an ambiguous, well, the crew will someday need this training, to have actual names and faces, it just makes it so much more exciting and real to anticipate getting into the classroom or the simulator or the mock-up with them and get them started on this journey.
What's going to be different about this? There's so much innovation.
A lot of things have changed in 50 years in terms of both what we know about the moon, what our experiences were on Apollo, and in terms of technology and what we have the capability to bring with us and equip the crew with. So we will have new lunar spacesuits, we will have very different innovative types of landers. The types of tools and experiments that we may have on the lunar surface are all going to be informed by the science that's been done since Apollo.
Establishing a permanent presence on the moon requires developing new technologies to provide the everyday things we take for granted on Earth, like water and electricity. So we've only explored a very small amount of the moon, and now we're going back to the South Pole. What can we learn?
The Apollo missions were able to explore roughly the equatorial regions, which would equate to about the continent of Africa, and we know how diverse that is. Now, if you compare it to the Earth, the rest of the moon is the rest of the Earth. So we've only explored 1 of 7 continents and the remainder of the surface area covered of water. So we have a huge amount of the surface of the moon that's left unexplored. In there you've got craters, which could be hiding water ice. There could be other resources from all the different impacts that are the craters and the pockmarks we lovingly look at the moon each night.
So we're going back to the moon to stay. What kind of architecture is needed? There's nothing there.
So imagine if you've ever been camping or backpacking, right? We take for granted that, yes, I'm carrying things with me, but on the surface of the moon, everything that I need, I have to take with me. I need my air to breathe, I need my food, I need my water, and so to think of it as the ultimate camping trip. In situ resource utilization, which basically means we're using the resources that we find and the sites that we're exploring, is very critical to our future plans. We've got to be able to know what's there and how we can utilize it best, and that reduces how much we need back from Earth. So that includes water from water ice, it includes propellants that we can create from breaking down that water ice, and also oxygen that we need to sustain life as we know it. If we can dream it, my job is to make sure the architecture is enabled to allow us to do it. So if it's science or if it's a town or a colony, as long as we have the will and the backing that we're able to accomplish that.
With anything this complex, it takes so much international collaboration to get it done.
With complex projects, collaboration is key. One of the cornerstones of our Moon to Mars program and the Artemis program in particular is the international collaboration and commercial partnerships. The Gateway program, which is soon to be planned for lunar orbit, also has contributions from various international partners. We're seeing a lot of interest globally along this.
The Orion spacecraft will take humans back to the moon, but getting to the moon is only half the challenge. The Gateway is an important part of the Artemis plan. It will offer the necessary aid for extended human missions on the moon and act as a starting point for missions deeper into space. The Gateway orbits around the moon, and it can also reposition itself with the most powerful electric propulsion system ever used in space. We're here at the Structures Lab of Maxar, where they're working on the PPE, the power and propulsion element for Gateway, part of Artemis. So Aditi, tell me about this.
Let's start with the Gateway. What is Gateway? Gateway is part of the overall Artemis mission, and this is humanity's chance of going back to the moon, and this time staying longer. This is one step before going to Mars. So Gateway is a formulation of a lot of different spacecraft that have different functions that will come and attach to each other and form a big configuration, just like the ISS, except now we are going all the way to the moon.
So how does this tie in?
So now we go down from Gateway to PPE. What is PPE? So the PPE is the power and propulsion element of the Gateway. We are providing power and propulsion to the entire Gateway. So we have thrusters that provide the propulsion and the attitude control, and then we have power through the large ROSAs, which are the rollout solar arrays. They are the highest capacity that Maxar has ever flown before. It's also the control element. So with all the sensors, actuators, and the propulsion system, PPE is the main control element for the entire Gateway.
So Aditi, this doesn't really look like a spacecraft yet. How's it going to get built?
Let's start with what we're looking at. This is the core structure of the PPE. This is the most integral part of our spacecraft. This is what holds everything together. The holes that you see are the inserts for panels. We'll talk about panels later, but that's where all the panels that go on. The panels are essentially where all the equipment that goes on the spacecraft sits.
So it's called the Gateway. It's made up of so many different components.
That's right. There are electrical components, there are components that move, and there are structural panels, some of which we have over here. If you've ever seen a rocket launch, you can see how the rocket shakes very violently. So you may ask yourself, what keeps the spacecraft from falling apart? It's because of the structure panels. The structure panels help the spacecraft survive the launch.
There's other space stations that have been built. What makes this one different?
The space stations that are currently on orbit now, they're close to the Earth. The Lunar Gateway is going to be out at the moon. When you start talking about going to the moon, you have wider temperature extremes, gets really hot, gets really cold out there, and you have a different radiation environment. How do you keep the equipment safe? And ultimately, how do you keep the astronauts safe in that environment? Those are the unique challenges that the Gateway program is solving. It is a place where science discoveries take place. It's a stopping point between the Earth and the moon. We're going back to the moon, and Gateway is just the beginning of this great space exploration adventure that we're on.
Other elements of the program include the Human Landing System and the Artemis Base Camp. The Human Landing System, or Lunar Lander, is charged with transporting astronauts between the Gateway and the surface of the moon. The Artemis Base Camp is a home base on the moon where astronauts will live when they're studying the lunar surface. The Artemis program is in its early stages, with missions planned through Artemis 5, and additional missions are being proposed. The goal here is sending a crew to Mars. We have a lot more to learn, but it's possible that some of the first people to go to Mars are alive today.
There's a lot at stake for all of us. Just because I'm working on this program, it doesn't mean it's important to me. I think each and every person on this planet can feel that they are part of this. This is going to change space, this is going to change technology, this is going to change engineering, this is going to change how we look at everything.
Why is space exploration important?
Space is important because it invigorates the imagination of everyone. It's a sense of adventure. What's around the next bend, what's over the next hill. Space is the next hill. People around the world, no matter where they are, no matter what they're doing, look up at the sky and they can wonder, what is that? And space exploration answers those questions.
It's going to be so exciting to look at the moon and say that there's another human, on that planet. And I helped build the spacecraft that got humans to another planet, and that is just keeps me going every day.
Each of these is a building block for the sustained lunar economy, and then eventually a stepping stone to Mars.
There's an immense amount of science to be learned in exploring the lunar vicinity and the lunar surface in a much more vast area than we did on Apollo. We're born to explore, and this is exactly what we're doing.
With Apollo, the U.S. inspired the world by the feat that we accomplished. With Artemis, we're inspiring the world to come with us to explore the moon again.
As far as space travel has come, there are still great distances to go. Here at Wings Over the Rockies, we're always diving into the magic of the solar system and the mysteries of deep space. We'll see you next time on Behind the Wings.
See you next time on Behind the Wings.